Day 559 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 110, balanced binary tree. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given the binary tree, determine if it is height balanced. All right, y'all. So before we get into these examples, let's take a look at the definition of height balanced to make sure we understand what's going on. It says, a height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. All right, y'all. So now that we know what height balanced is, let's take a look at these examples. So in example 1, we have our input root, which is a binary tree, 3, 9, 20, 0, 15, and 7. The output is true. They give us this handy dandy picture up here so we can see for ourselves that this height is balanced. As you can see, it says right here, the depth of the two subtrees of every node never differs by more than one. So as you can see, this is the depth right here, right? It has this 20 has two child nodes. This 9 doesn't have any child nodes, but since the depth right here is only differs by 1, then that means the tree is balanced, and it's true. So you can see this 9 doesn't need any children nodes for it to still be balanced, even though 20 has the children nodes. As long as the 15 and 7 do not have any children nodes, then it's still balanced, and the height is just differed by 1, like it says right here. Boom. Now let's take a look at example 2, where it's a binary tree that's not balanced. So in example 2, we have our input root equals a binary tree 1, 2, 2, 3, 3, 0, 4, 4. The output is false because, as you can see, this depth does not differ by 1. So say this is the most shallow part, right? This 2. Say this 2 is the shallow part. This 2 right here has a child node, which would be fine, right? This if these 3s didn't have child nodes. Since this 3 also has children nodes, the depth is no longer differing by 1. Now it's differing by 2, right? Because it was differing by 1 when this 2 had these 3 children nodes right here. Boom, right? It still only differed by 1. But as soon as this third child node had 2 more children nodes right here where these 4s are, it no longer differs by 1, and the output is false. So let's take a look at example 3. In example 3, we have our root equals a blank binary tree, and the output is true because it's blank, so it's balanced. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So first thing we want to do is we're going to create a helper function. So we're going to say private func check height, open up the parentheses, underscore node, colon, it's going to be a tree node, question mark, come outside the parentheses, and it's going to return an integer just like this, and then we're going to open up the brackets. Now, first we're going to handle a base case. If the node is nil or empty tree like it was in example 3, then we could just automatically return 0 as the height. So we're going to come right here, and we are going to say, and I'll tell you why that 0 is important once we get into the main function. But for now, we could just say guard let node equal node, else we could open up the brackets and we could return 0. Boom. And once again, I'll tell you why the 0 is important once we get into the main function. Boom. Now we're going to recursively check the height of the left subtree by saying let me clean this up for y'all. We're going to say let left equal check height, open up the parentheses, we're going to pass in node.left. Then if the left subtree is unbalanced, we're going to propagate -1 up words immediately, meaning we're just going to return -1 and we're going to propagate it up to this function immediately. And I'll tell you why that's important once we get into that function. You'll see. So we're going to say if left equals -1, then we can open the brackets and we can return -1. Boom. Then we need to recursively check the height of the right subtree. So for that, we're going to say let right equal check height, open of the parentheses. This time we're going to say node dot right. Boom. Then if the right subtree is unbalanced, we're going to do the same thing and return -1 right away. So we're going to say if right equals -1, then we're going to open up the brackets and we're going to return -1. Boom. And if the height difference between the left and right subtree is greater than 1, the current node is unbalanced, so we return -1 to signal the imbalance. And that's what we're going to do, sorry y'all, right here. When I say if ABS, open up the parentheses, left minus right is greater than 1, then we can open up the brackets, and you guessed it, we can return -1. Boom. And if balanced, we're going to return the height of the current node, which is 1, plus the maximum of the left and right subtree heights. So for that, we come right here, and we're going to say return max, open up the parentheses, left, comma, right, come outside of those parentheses and say +1, right? So if all of these, if we make it past all of these, then we're going to return this right here. And then up here, we're going to say, we're going to call the helper function starting from the root node. And if check height returns -1, then that means the tree is unbalanced. Otherwise, the tree is balanced. So all we're going to do is we're going to see if this check height function returns -1. And as you can see, it has all of these chances right here to return -1. So it's highly possible that it might return -1. So all we're going to do is say check height. We're going to call the function, pass in the root. So open up the parentheses, pass in root. We're going to say exclamation point equals -1. Now what this is going to do is it's going to return a Boolean. If it does not equal -1, then it's going to return true. But if this is false and it does return -1, then it's going to return false, right? So all this is saying check root does not equal -1. If it does equal -1, then it's going to return true. If it doesn't equal -1, because remember this says it doesn't equal -1. So if this is true and it doesn't equal -1, then it's going to return true. So let's go ahead and give this a run. Make sure it runs properly before we submit it. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. And yeah, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.